In this lecture, basically, I am going to discuss about the meaning of signals, how you will define signals, what is signals, and what are its various types. So these two parts I will cover in this lecture. So the first question is, uh, what is signals? How you can define signals? What is the meaning of signal? How you can easily define the meaning of signal? Signal is basically a physical quantity. Signal, voltage can be a signal. Voltage is a physical quantity and it can be a signal. Current is a physical quantity and it can be a signal. Pressure is a physical quantity and it can be a signal. Temperature can be a signal. Any physical quantity can be a signal if that physical quantity varies with time, space, or any independent variable. Time, space, or any other independent variable, then you can say the physical quantities are signal. For example, pressure. It is a signal and it is a function of independent variable height. As the altitude, as the height will change, pressure will change. So pressure is a signal and here independent variable is height. Similarly, current, voltage, all are the signal. As the time will change, current will change. As the time will change, voltage will change. So these type of physical quantities that are the function of time, space, or any other independent variable, then you can say that physical quantities are signal. Suppose this is a physical quantity, and if you are saying that this is a signal, it means this physical quantity may be a function of time, it can be a function of space, or it can be a function of any independent variable, or it can be a function of combination of these three. So the definition is clear. But the other important thing is not the physical quantity is only function of these three things, time, space, or independent variable. Signal must possesses some valuable information also. Signal must include in itself some valuable information. And that valuable information can be extracted through entities, and that entities are called system. So signals and system both are important. Signal will carry some information and system will extract that information. Voltage is a signal and fan is a system. Current is a signals and fan is a system. Fan will convert that electrical signal into some valuable information. It will give if you will give input to the system, it will give output from that signal. It will extract the valuable information from the signals. So for system is also required to extract information from the signals. So the basic definition is physical quantities, and that quantities should be a function of time, space, and any other independent variable, and it must possess some valuable information. These are the basic definition of the signal. And third, an important point is quantitative description of any physical phenomena or event or the process. This is very important point. If you want a quantitative description of any physical phenomena, how you will quantify uh, physical phenomena? You can quantify through a signal. So in conclusion, you can say signal is a physical quantity, and that physical quantity varies with time, space, and any other independent variable. And this physical quantity must possesses some valuable information in it. It must consist some valuable information. So this is about the signals. There are various types of signals. You can say voltage and currents are signals, and speech signals. There are various examples of signals. Here you can see the examples of signals: speech signals, video signals, voltage signals, current signals, radio signals. These are the examples of the signal. And you can see in this picture how the strength of a speech signal is changing with the time. So here the amplitude of the speech signal is a function of time. So it is a signal. Here you can say how the amplitude of radio signal is changing with respect to time. Here you can say how the amplitude of voltage and current are changing with respect to time. So these are the examples of signals. Basically, signals are defined. Signals are categorized in two groups. This is basic classifications of the signals, basic types of the signals, and under this heading there will be various subcategories also. But this is a basic types, basic category, basic classification of signal. You can say there are only two types of signals. One is continuous time signal, and another one is discrete time signal. And the definition is clear. Continuous time signal. What is continuous time signal? The signal which strength, which amplitude can be defined for each and every instant of time. Means the signal which amplitude, which strength can be obtained. If the amplitude or strength of the signal can be obtained at each and every value of time, then that type of signal is called continuous time signal. For example, this is the representation of signal which is varied with time, and this is the plot. This is the plot. This is the graph of the signal. This is the, you can see the, you can say the characteristics of signal. And, this vertical height is called amplitude of the signal. So in this plot you can see the amplitude can be defined at each and every instant of time. Such signal which amplitude, which strength can be defined at any instant of time, or it is defined in entire range of time, then that type of signal is called continuous time signal. Continuous time signal is also called analog signal. Continuous time signal is called also called analog signal. This is called analog signal. Example of continuous time signal is a speech signal. The strength of speech signal can be defined at any value of time. If you want to determine amplitude of a speech signal at this point, then you can define the amplitude at this point. At each and every point, you can define the amplitude of the signal. This is a continuous time signal. At each and every point on time axis, there will be an amplitude of voltage or current. Suppose what is the amplitude of voltage at this point? The amplitude will be this. What is amplitude of the current at this point? amplitude will be this. So at each and every point you can define the amplitude of the signal, or you can say continuous time signals are defined. Its amplitudes can be obtained at entire range of the time. So such type of signals are called continuous time signal. These are the example of continuous time signal: speed signal, current and voltage signal. Atmospheric pressure as a function of height. As the height will change, atmospheric pressure will change, and at each and every height you can determine the amplitude of the pressure. You cannot say, you cannot define, you cannot say its pressure is not defined at h equal to 3 meter. You cannot say this, because at h equal to 3 meter, 4 meter, 3.1 meter, 3.2 meter, at any height you can estimate the value of pressure. So it is a continuous time signal. And what will be the discrete time signal? Discrete time signal cannot be defined. Its amplitude cannot be obtained at each and every sample point, at each and every instant of time. It is only defined for certain sample point. For example, this is a discrete time signal and its amplitude only defined at 10 sample point. Amplitude, you can define its amplitude only at 10 sample points. If you want to define its amplitude at this point, then its amplitude at this point is not defined. You cannot say its amplitude at this point is zero. The correct answer is its amplitude at this point is not defined. Its amplitude at this point is not defined. Its amplitude at this point is not defined. Its amplitude is defined only here, at this point, at this point, at this point, at origin, at this point, at the only at 10 sample point you can define its amplitude. Beyond this 10 point you cannot define its amplitude. So discrete time signal cannot be defined. Amplitude of the strength of the discrete time signal cannot be defined at each and every point. So this is the difference between continuous time signal and discrete time signal. Discrete time signal has some discrete set of value. In this example, there are only 10 sets of its magnitude. And this discrete set of value is also called digital value. Or you can say discrete time signal is also called digital signal. Digital signal. Now, this is the main classification of signals. There are two types of signal: continuous time signal and discrete time signal. And under the heading of continuous time signal or discrete time signal, there are various subcategories. Means there are various types of continuous time signal and there are various types of discrete time signal. For example, deterministic signal and non-deterministic signal. Deterministic signal can be a continuous time type or it can be a discrete time type. So under the heading of continuous time signal, there are number of other subcategories. And one by one, I am going to discuss that types of signals. The same definition will be true for discrete time signal. I am going to discuss for continuous time signal, but the same definition is for discrete time signal. The only difference is it is defined for entire range of time, but discrete time signal is only defined for some sample point. And discrete time signal is also a very important type of signal. And that is why you are going to study about discrete time signal also. This is very important signal, and you will later you will study how you will convert continuous time signal in discrete time signal and again reconstruct discrete time signal in continuous time signal. In next few lecture you will know about this. Now, what is deterministic signal? First, you must remember deterministic signal can be a uh, continuous time or it can be a discrete time. The deterministic mean the signal which characteristics, which descriptions, which nature can be completely known to you. You can predict its nature, its characteristics at any instant of time. Means no uncertainty with respect to its value at any instant of time. For example, this is any physical quantity which is vary with time. This is a signal. Now, at any instant of time, this is a regular. You can, if this angle is 45 degree, 5 degree, then you can write a equation between x and t. And for any instant of time, you can determine the amplitude of this signal. And you can also determine its magnitude in advance. Suppose its value is known at t equal to 1. Then you can predict its value at t equal to 5 seconds, at t equal to 6 seconds. At any instant of time in advance, you can predict its value. So that type of signal is called deterministic signal. Means no uncertainty with respect to its value at any instant of time. Suppose this is a signal. This is deterministic signal. This is a deterministic signal because you can uh, first you can convert from this plot. You can write a mathematical equation, and from that mathematical equation you can determine its amplitude, its strength of the signal at any instant of time. So this is a deterministic signal. It is a regular signal and it can be defined exactly by mathematical formula. This is very important. You can write mathematical formula for deterministic signal. This is a deterministic signal, and you can write a formula for this signal. X equal to a sin omega t, a sin omega t. And from this mathematical expression, or you can say from this plot, you can determine its strength at any times. Or you can also extend plot. You can also extend the plot. Similarly, this is a deterministic signal because its characteristics is clearly known. You can draw a plot. If n is greater than 0, then its value is 2. Its value is 2. This is 2. And if n is less than 0, its value is 0. So its characteristic is clear. You can determine strength of signal at any value of n. What is the value of the signal when n equal to 5? The value of signal is strength of the signal is 2. What is the value of strength of the signal when x is minus 3? It is less than 0, so its value will be 0. Similarly, you can draw a plot from this mathematical expression, or you can say you can determine its strength at any value of omega t. So no uncertainty with respect to its value. You cannot say at t equal to this, we cannot determine its value at any value of time. you can determine at any instant of time, you can determine its strength. It is a regular signal. You can extend the deterministic signal if you want. You know its complete characteristic or physical description. So such type of signal is deterministic signal. But non-deterministic signal. What is non-deterministic signal? Its nature. What is non-deterministic signal? Non-deterministic signal, or you can say the random signal. Its nature or characteristic cannot be predicted in advance. You cannot say what will be the characteristic of this voltage signal after beyond this time. It can be like this, it can be like this, it can be like this. You cannot predict what will be its characteristic beyond t. Means there is uncertainty with respect to its value at any instant of time. What will be its value at any instant of time, you cannot predict. It can be a 2 volt, it can be a 5 volt, it can be a 0 volt. So you cannot predict its value at any instant of time. Pattern of such signals are quite irregular. You cannot extend its pattern. What will be? You can extend its pattern. What will be its second cycle? You can easily draw its second cycle. You can easily draw its third cycle. This is a regular signal. And this is deterministic signal. But what will be its pattern after this point? Can you predict what will be its pattern after this point? It can be like this after this point. Or it can be like this. You cannot predict what will be its characteristic beyond this point. You cannot predict. But its characteristic, you can predict what will be its nature after this point. You can easily extend this plot because this is a deterministic signal. But for non-deterministic signal, for random signal, uncertain, there will be uncertainty with respect to its value at any instant of time. Pattern of such signal will not be regular, and the main and important thing, you cannot write mathematical equation of this signal. This is the important point. You cannot write mathematical equation of this signal. And if you are not able to write mathematical expression of any signal, then you can say this is non-deterministic signal. What will be the mathematical equation of this signal? What will be the mathematical equation of this signal? You cannot write the mathematical equation of this signal. If this is a physical quantity x and this is t, then what will be the mathematical equation between? What is the relation between x and t? You cannot predict. You cannot write because you do not know the characteristics of such signal. Its characteristic is not predicted. Its nature is not predicted. So you cannot write any mathematical expression for such type of signal. But if I am asking you what will be the mathematical expression for this signal, this is a straight line passing through origin. You can easily write if this is angle theta, then the equation will be y equal to, or if this is x, and this is time, then equation you can easily write x equal to m into t, y equal to m into x. So this is a deterministic signal. if you are able to write mathematical expression from the plot, then it is deterministic. And if you are not able to write mathematical expression from the plot, then it is non-deterministic signal or random signal. Noise exists in electricity. Random noise exists in electrical engineering is an example of non-deterministic signal. And voltage and current uh, that are existing in your electrical engineering are the deterministic signal. So this is the type of signal, not only deterministic and non-deterministic. In next lecture, we will study about periodic and aperiodic signal. In addition to periodic and aperiodic signal, there are various other types of signal also. So we will study about that types also in next lecture. So this is all about this lecture. Thank you.